Okay, we have this situation. This is a profit versus selling price model. Okay, we did the revenue versus selling price in the latter part of our last class. Now you can't quite read the top here, but you can see everything on the graph, and I'll explain. This is the price along this axis. And the intercept along the axis is 50, 0, and the intercept up here is 0, 5,000, where, again, this is the price, and this is the number you sell. So one thing it tells you, if you're giving them away, 0 price, 5,000 people are going to want one. Nobody else has room for the darn thing. Okay. Or nobody wants to do the maintenance on it, whatever. Okay. And 50, 0 out here. What's that tell you? Well, if you're at this point, you're charging $50 and you're selling none. Okay. This is the price. This is your number sold. This is your price. This is your number sold. So N is a function of P. And the way I've drawn the graph, it's a linear function of P. Now, we talked last time about how in the real world, you don't really expect a linear function, but you can still get a lot of information and a lot of feel for the idea by assuming it's a linear function. Okay. So there's your linear function. What is that function? If you're a distance student or somebody else who's trying to learn a little something from this, hopefully a lot of something, then this is a good place to stop and see if you can answer this question. And then you can look at the subsequent questions. If you get this answer, sure, go ahead, see if you can give the revenue function. We did that at the end of class last time, but of course I'm going to explain that again because it's new. And then we go a little further. Now, we didn't do this part last time. We said if the cost is $1,000 plus $10 per item, then what is the profit function? Okay, now there's terminology there you might not know, and we'll get to that. But right now, you can stop and see if you can find the function N of P that matches this graph. Okay, well, hopefully, if you're watching, you've actually done that or attempted it. I'll repeat the graph here. This is P. This is N. There's the graph. Well, it's a linear function. N is a linear function of P. So N equals MP plus B for some N and some B. To get the slope, what do you do? Well, you have 2 points on the line. There's a formula for getting slope, which I don't encourage people to think of first. I encourage people to skip what I call a fundamental triangle between 2 known points. We go from the leftmost to the rightmost point along the path like so. Of course, we can go along the path like so. This path is the rise, which is where we end at N equals 0 minus where we begin at N equals 500, 5,000. Now you can just see that we're going from 5,000 down to 0, so we're doing negative 5,000. So if you get a plus 5,000, it doesn't match your arrow, does it? Okay, so you want to be careful about that. And then from left to right, we have to go 50 units here. It's pretty obvious. Here we're P equals, N equals 0, P equals 0, and here we're P equals 50. So the run equals 50 minus 0 equals 50. So the slope equals rise over run equals negative 5,000 over 50 equals negative 100. And we put a box around that. We actually didn't leave myself enough room to do it, but I'll do it small. We put our negative 100 here, somewhere along the sloping line with a box around it. So now we can refer back to this picture anytime we feel like we might have made a mistake. And you know, I did all of that with this thing off the camera because I had the camera aimed. For the original statement of the problem. So anyhow, there it is. This should be familiar. We construct the fundamental triangle. Arrows going from the leftmost to the rightmost point, a direct arrow, and then arrows take us on a path along the legs of the triangle. We label the rise, we label the run, we calculate the slope, and we put the slope in a box. And there's reason for me advocating that you do all this. One reason is, on the final exam, if you're in my course, I could well ask you to do this. If you're not in my course, I still recommend that you understand this, because first thing you do in calculus after you do limits is you do the derivative, and this triangle is very relevant to that. And if you don't have a good feel for this triangle and what it tells you, it's going to be a little harder for you to understand what a derivative is. Okay? So I want to give you that background. Again, this is not standard. Not everybody is going to teach you this. I'm probably the only one in the world that uses this thing I call the fundamental triangle, but they appear 1,000 times in your mathematical future. Okay? So I'll give it a name and formalize what we do. Okay. Now we know that m equals mp plus b. Why did we bother finding the slope? Well, that's the slope. It's just like a y equals mx plus b. But we're replacing y by n, and we're replacing x by p. Okay, so we get this equation. So now we know that n equals 100p plus b. Now, what's b? Well, b is our y-intercept, so that makes it easy, because the y-intercept is 5,000. N equals 100p plus 5,000. That means, for example, if the price is $20, then we're going to sell 20, then we're going to sell how many of these things? Well, 20, uh-oh. I put the negative sign in there, I didn't put it in here. Okay, we have to have that negative sign. If the price is $20, this multiplies out to negative 2,000. Okay, if we add negative 2,000 to 5,000, we get 3,000. Okay, so that means we're going to sell 3,000 of these things. Now at this point, You'd say, okay, if we sell 3,000 of them at $20, it's gonna be $60,000. Okay? It's pretty good revenue. Of course, it costs us $78 million to set up our factory. I don't know if that's necessarily gonna be a good return. But seriously, we've got, and what we did before was we went ahead and multiplied this. By what? By the price, okay? Multiply the number we sell by the price, we get the revenue. Okay. Now, I added something to this one. Okay. So right now, I'm just gonna write that down conceptually. That's our revenue. Once we have our function that gives us the number of sold as a function of the price, we can multiply that by the price and see how much money we're gonna take in. All right. Now we go on to the cost function. What did I tell you? You know, the cost is $1,000 plus $10 per item. Okay, how many items are we talking about? Okay, people are working on this, but you know, if you're watching the video and you've gotten to this point and aren't sure what to do, let me just say again. Okay, here's the situation. We use this function to predict how many we're going to sell for whatever price we set. So we can set the price. We're going to set the price somewhere between $0 and $50 because we know if we sell 0, we don't get any money. And if we put it at $50, we don't sell any and we don't get any money. Okay, so there is the function. We decide the sliding scale, you know, where do we set the price? All right. We're actually trying to decide where we set the price, but once we've decided, that's going to determine N. Now, the cost function is what? $10 per item plus $1,000. So we set a price that gives us a number that we sell. How does that tell us what the cost is? Actually, let's assume that you set the price at $10. Okay? So your price is $10. What does this function tell you? You're going to get a specific number here, right? And then you're going to tell me what the cost is. So if you set the price at $10, how many do you manufacture and what therefore is the cost? You know, a little stuck on the cost. But you know what we see is cost is $10,000 plus $10 per item. Now let's just work something out. Let's say we set a price. let's say we set the price. So we're just gonna play with this a bit. The price is $10, and it's easy to see. And N equals what? Well, negative 100 times the price plus 5,000. Work that out yourself, but you'll find that it's 4,000, right? If the price is $30, then what does that equal? Well, we'll put 30 in for P. Negative 100 times 30 is negative 3,000. Add that to 5,000, we get 2,000. Well, that is 4,000. And the cost is what? It says the cost is $1,000 plus $10 per item. Then it's going to be 1,000 plus $10 times the number of items. Cost per item is $10, and you manufacture 4,000 of them. This term is going to give you 30,000. And you add that to the 1,000, it's going to cost you $41,000 to manufacture these things. Okay. Now, that's a good strategy when you're not sure where to go in a problem, or you think you know, but you're not sure you're right. Work it through. We start with price. Okay, we start with price. We set a price somewhere between $0 and $50. Just do it with numbers. That'll tell you what you have to do with the symbols. So we set it at $10. We find that the price is 4,000. We set it at $30. We find that the price. Sorry, we set it at $30. Set it at $10. We find that we sell 4,000 of the number is 4,000. Set the price at $30. We find that the number is 2,000. Okay. And we could put 2,000 in here. You put 2,000 into this. It's only going to cost us 21,000 if we set the price at $30. The higher we set the price, the fewer we have to manufacture. Okay. The fewer we're going to have to sell. But of course, we're selling them for a greater price. So we have two trends here. The greater the price, the fewer we sell. But the greater the price, the more we sell. How does that balance out? All right. What do you think about that? Okay. We're skipping to the cost function here. Let me erase this here. We're going to spend a little more time on this because we want to make sure we understand. So up here, I can say summarizing. If I tell you what the price is, you're going to be able to tell me what the cost is. Okay. So there's two statements. Now, same thing if we call the price P. If you know the price, how do you figure out what your cost is? Okay, now, if you answered the question I just erased, I'm going to rewrite it. I'm going to put an extra step in here, break it down a little further, right? If n's the number sold, then what's your cost? Okay, what you did, I think is good, but it's not necessary. You can answer the question directly without doing that. And as a function of P, formula's right there. Sorry. Oh, heck, have I not been recording? There was some confusion maybe with the recording, but what we did was, okay, it comes down to this. If the price is $10 and it's 4,000, so the cost being 1,000 plus 10 times $10 times the number you sell, $10 per item. If you manufacture 4,000 items, then you're going to have $10 times 4,000. And we've been over that. I'm pretty sure that came out. If the price is $30, then the cost is going to be $10,000 plus $10 times the 2,000 items you manufacture if you charge $30. So we've seen that. Following the same logic, if N is the number sold, then what's the cost? Well, here we did $1,000 plus $10 times the number of items. Here we did $1,000 plus $10,000 times the number of items. The number of items changed because we raised the price from $20 to $30. okay? They come to the conclusion the cost has to be $1,000 plus $10 times N. Now, if the price is P, then N is negative 100 P plus B, because that's the function that we got instantly when we saw this graph. So we use that to determine what N is. Now we have N as a function of P, and the cost is a function of N. Now this is actually a composite function, okay? Cost is 1,000 plus $10 times N. N is negative 100 P plus B. And I've got plus B, but we've determined that B is 5,000. So now we're going to say the cost is $1,000 plus $10 times N. N is negative 1,000 P plus 5,000. Put all that together, here's a cost function. Now, the question I've just asked is, in terms of P, what is the revenue? It's P times N, but N is a function of P. So what is N in terms of P? Well, think about that. Stop the video, think about it until you get the idea. Hopefully you get it before I tell you, but I'm going to tell you. Okay, hopefully you paused and figured it out. N is negative 100 P plus 5,000. So if the revenue is P times N, we get this. And there's our revenue. Now, what's our profit? Profit is our revenue. So we take in $100,000 maybe. Profit is our revenue. Minus our cost. So can you now write down for me the profit function? Okay, well, hopefully everybody's gotten it. Okay, now hopefully everybody who's listening has gotten this. Again, cost is revenue minus profit is revenue minus cost. That's common sense. Think about it. Here's your revenue. Here's your cost. Well, there it is. Now, can you multiply that out and simplify it? Well, I assume you can, but we've only got 2 minutes left. So I'll go ahead and do it. If we multiply this, we're going to get negative 100 P squared plus 5,000 P. That's going to be minus 1,000 minus 1,000 P minus negative 1,000 P. Okay, no, minus all this. Plus 50,000, because we multiply 10 by all this, that's what we get. And we can simplify this. And ultimately we get negative 100 P squared plus 6,000 P minus 51,000. Now this quadratic function we use what we know about quadratic functions. Axis of symmetry. Is negative b over 2a, which is negative 6,000 over 2 times negative 100, which is 30. That's right. There's p equals 30. Y-intercept is negative 51,000. So that's down here somewhere. I'm using Y. We'll call Y the profit because we're using P for the price. Y is negative 51,000. X-intercepts are at X equals negative 6,000 plus the square root of 6,000 is 3.6 million, 36 million, I'm sorry. So that would be 35 million 949,000 over 2 times negative 100. Okay, well, this divided by this is like 30. The square root of this is like 6,000, and that's ridiculous. Should be minus 4 times that, but that doesn't help a lot. That's 4AC. Okay, I did. Okay, so that's going to be like close to 800,000. And then it's minus 4AC, which is minus 4 times 510,000. Well, I'm not going to do the numbers now, but you would get two numbers here. Okay, so you got an x-intercept or y-intercept here. Sorry, yeah, you got your y-intercept here, and you're going to get a graph that takes your axis of symmetry. And that's how you do it. And somehow those numbers aren't working right for me. 5 million. It's like 20 million. It'll be like 16 million. It's going to be like 4,000. You're going to get like 2,000 over 200. Which is like plus or minus 10. 10 goes through the city. Okay, the numbers don't work. But you understand, we just do little algebra once we make the meanings clear. We've talked about how to get the meanings out of the situation, out of the information. We get a quadratic function and we'll figure out what the peak is. It'll be on the axis of symmetry. Okay.